Hello. Okay, today, folks, we're going to get straight into it. We're not going to faff around having a quick chit chat because we have too much content to get through in today's episode, which is going to be about how to actually migrate an EC2 instance on x86 to Graviton. I have two amazing guests. Rem, you have met before. Hi, Rem.
Hey everyone, good to be back.
And Hanara, you have not met. So, Hanara, let's get into it with your 1 minute origin story before we start. So, tell everyone who you are.
Hi everyone, I'm Hanara. I'm based in New York City. I've been at Amazon for just a little bit over 5 years now. And I am a Graviton specialist SA. So I help our customers make the transition to adopt Graviton. And it comes with all sorts of different walks of questions, from performance to compatibility to just trying to lower costs.
Awesome. All right, nice and simple. And today, like I said, we're going to have an exciting conversation about how to actually move workloads. Oh, I must didn't do my actual intro, which is I got so excited about talking about the subject. So welcome everyone to the Keys to AWS Optimization, the show we share stories, concepts, and solutions to help you unlock your spend at AWS. My name is Steph, should introduce myself, and I am your local FinOps advocate here to answer and help all of your questions around FinOps. And just as a reminder, if you're watching us on YouTube, don't forget to hit that subscribe button to stay up to date with all of our content. And if you're watching us live on Twitch, welcome. And remember to subscribe to the Twitch channel. So many amazing shows on all different days. Okay, so back to it. We're going to be doing a video today. So this one is going to be, if you are a FinOps person at a company and you want to encourage your developers to move to Graviton, this is the video to send to them. This is the one we're actually going to take you through the process of doing it so you can share that information. And Rem, why don't I hand it to you before we actually do the demo to talk a little bit about Graviton 4?
Yeah, I was going to say, I know that this is more about just moving to any type of Graviton, but even since I was on a month ago, we have a new Graviton processor that's now GA, and that is Graviton 4. So in the usual Graviton fashion, we've got a lot of bump in specs for Graviton 4. Just to hit you with the highlights, we've got 30% better compute, 50% more cores, 75% better bandwidth. But honestly, I think one of the things that is coolest about Graviton 4 and I'm most excited about is some of the different size options. So first, in the single socket design, we have now up to the 24XL. Previously, for other gens of Graviton, we were only going up to 16XL. So that is now up to 96 vCPU for single socket. But also for the first time, we have multi-socket support. And so that's going to get you up to 48XL. And if you go up there, that's 3 times as many cores as you would have on any other Graviton processor. So really great for database, in-memory cache, big data workloads, and some really, really cool things that you can do with that.
I didn't even know there was a wait, I must have known that. I'm trying to remember, like, did I know there was a 48 size instance type? And Ren, we talked about how there were so many different instance types available. So kicking us off with a quick poll in the chat, how many instance types do we have? Out of curiosity, who knows what one we have? I'm gonna give it a second, but 1 for 350 plus, 2 for 550, and 3 for 750. What are we guessing? Okay, a couple for 550. This is Ren. When was this like the number that you shared that this was like announced?
This is now that Graviton 4 is GA. So this is late breaking stuff.
Okay. So number 2, which is 550, is winning. Rem, what is the answer?
We are now over 750, which is pretty crazy to think.
That's too many. No, joking, not too many. There are just so many. I love it. Amazing. Thank you everyone in the chat. And as always, throughout the chat, please feel free to put questions, comments in there. We're reading them and sharing them. Target Practice says, wow, I feel the same, that there's that many. So it's amazing. Okay, Hanara, give us a summary of what you're going to be demoing. You are the Graviton expert and get to do this all the time. So let us know what you're going to talk us through today.
So we're going to migrate over a web app that's using a C++ library. this is actually part of a workshop that we have. We have events going on around different cities. So if you are interested in doing the demo that we're doing today in person, do let your account teams know. And we'd love to host an event in whatever city you're in. So we're going to be migrating over this application. There's 4 applications that have these kinds of shared libraries. There's some additional knowledge to know about when you're moving from different platform to platform. So I'll talk a little bit about that. I'll show a quick infrastructure slide of what we'll be going through today. Not going to try to not be super slide heavy. We only have like 4. So bear with me when I show it. I know we really like to be on the accounts, the AWS accounts here. And so we'll walk through what kind of migration strategy you want to have, some tools that can help you identify what workloads are compatible. We'll run through those in the demo as well. And then we will do some testing in what would be like our test environment, not in production. How do you find out that your web app is appropriate for Graviton in your test environments? Then we'll do a little bit of performance testing and then start deploying the instances, the images that are set for Graviton onto Graviton through autoscaling groups. So we're going to go through the whole thing, and it's going to be a little bit of like a I don't know, how would you say, like a sample of what your migration would be, because obviously we're going to try to knock this out in like 40 minutes.
Yeah.
So if there's any questions, please feel free to throw it into chat. If we can't get to them, I would love to talk, and feel free to reach out to your account teams if you need more support. And lastly, as like a bonus, there was a new feature that was launched for Amazon Q developer agent that helps you upgrade your Java applications from 8 to 17. And that's using Gen AI. So on Graviton, we'll talk about this a little bit more, but Java 8 is compatible, but you really get that performance boost once you go to Java 11 and so on. So if you're putting the effort to do this migration, it's really nice to be able to let that lift of modernizing your applications to a LLM and then enjoy the performance benefits and really cut down your costs in that way as well. So got a lot of stuff to do, and let's get into it. So I will share.
And while you're getting your screen up, what I'll say is, if you want to see a summary of this episode written down rather than just the video, check out the community hub, which we post all kind of summaries of our episodes now. So you can see that, and we'll be sharing all the links in the below chat for the YouTube video. So just make sure to subscribe, and then you'll stay up to date with all this stuff. So it's all good. Okay, let's see that screen. Perfect.
Cool. All right. This is the overview if we ever get lost, but just a quick architecture diagram of our demo today. If my mouse will cooperate with me, okay, that's all right. We're doing this.
There we go.
So we've got a Visual Studio editor that's installed into a remote server in the AWS account. This is going to be Graviton instance that we're working on. And I also have an x86 IDE server as well prepared. So just to show the side-by-side of what you would do differently. Spoiler alert, it's really not that different. You're going to have the same process. A lot of it will just be part of the infrastructure part. This is granted that you have updated software that's compatible for different architectures. Then we'll have a code pipeline that's going to be deploying the infrastructure. The code repository for the actual application is in its own separate code commit. Code repository, we're just using that as a source for the application code for the test environment, as well as the EC2 image builder, which will be pulling directly from code commit to deploy into our lovely quote unquote prod infrastructure with auto-scaling groups and built-in AMIs so that you have all of those really scalable mechanisms to ease your development. So a lot of the conversations that kind of happen when we talk about Graviton really comes down to software hygiene and having a really healthy DevOps lifecycle as well. Because if you don't have that and you're doing a lot of stuff manually, the lift is going to be bigger. But, you know, this doesn't just go for Graviton. You also want to have a solid DevOps lifecycle for building out new features as well. So when we work with customers, there's like a nice balance of you get to also just make sure that your applications will be set for the future as well for any future iterations you might want to do. So, all right. So this is the chatbot service we're going to be using just to show you that we're pulling in this library. And in the workshop that we have, there's 3 different languages we go through. We're going to go through Java. So, all right, enough of those slides. Let's go
Get rid of those slides.
into the code. So here I have quite a bit of instances up and running. I have my Graviton instance. This is where the IDE is installed, and we'll be building some stuff in here. We also have a load test server. This is a separate instance that can send a good amount of load into our test instances, as well as our and just environment in general to get a sense of the performance that we'll be getting. And then we have another instance here for building our actual Graviton instances. And to be honest, I did a little bit of play around and I might have messed with the code pipeline a little bit. So there's also supposed to be a Graviton build agent as well. And we'll talk about why it's important to build natively if that's possible.
Right. So some of the assumption here is that this stuff already exists in people's organization, like the load testing, like the IDE, so that kind of is there. And then we're just focusing on your application, right?
Yes. So we're not building from scratch here, right? Like we're pretending today that we are already a developer. We have all of these environments set out for us. And there's a lot of Terraform files here too, as you can see, that we'll walk through a couple of them just to show you. But the intention is not to rebuild all of these infrastructures. I have 2 instances, one for Graviton and x86 side by side. We're just going to show you which parameters and variables you'll want to update in order to have an additional instance family type for whatever architecture you might choose to use. And we'll also talk about if you want to have both x86 and Graviton instances, especially if you're running like spot workloads. So we'll talk more about that. A lot of, prologue here. So let's see. I always forget which is which. Okay, so this one's my Arch 64. And this one's okay, that's my x86. Cool. So we're going to be building out our Java application here. And I'll start with x86. And again, like this is intended to not be so different from what you're doing today. Right. We're just going to do Maven clean package. If you're a Java developer, there's nothing crazy here. And then we're just going to install the dependencies that we have for this application. Like mentioned before, there's a C++ app in here that we'll be referencing. So if we take a look
at
these, go ahead.
Graviton dependencies or just dependencies for the code itself?
This is dependencies for the code. libraries. There's Graviton. We have a Graviton shared object, and we have an x86 shared object as well. So perfect stuff. You set me up for going through the Java app. Super simple app, just one file for the actual code portion. But if we scroll down, we're dynamically linking this library here.
I don't know if I zoom in like one beat just to
yes.
make that a little bit clearer if possible.
I
feel like I ask anybody whenever we demo, it's always like, zoom in more than you think we're going to need, because it's I don't know if I'm blind or if it's my computer quality. That's perfect. Thank you.
Good call. Actually, I don't know why I didn't zoom in before, because I couldn't even see myself. So we have this identifier here for which library we'll be using for this chatbot. Takes into account whatever the OS architecture of the actual processor is. And since we're on a Graviton instance, it's going to use the conditional to use the ARM64 shared object. And we did the compilation for this library outside of this demo and the workshop as well, just because you typically will pull in these shared objects from wherever you might be pulling your libraries now. If you're handwriting these libraries, then obviously you are in charge of compiling it. And I'll show a link in the GitHub. Actually, I think I have it in our little deck somewhere in our clip sheet. The Graviton Getting Started Guide for Java. There's a little section in there that shows how to create shared objects for both architectures. And the reason why there might be some kind of shared objects like this, they're usually using machine code, lower level code, like C++ or C to improve performance. So if you don't have one that's architecture specific for one or the other, you might see a performance difference. And pulling in that architecture specific shared object will really help with performance as well. So looks good. We have our application running now. I think I should be able to click into it even. I might not be able to because we have security groups locked down. So I will do this instead, just so we can see that it's up and running. Nope, that's not
That's
good.
the thing. Don't come on there.
Don't come here.
Okay. Can you imagine to get all these people joining?
Okay, cool. So we're up and running on port 8081. And cool. So we see that it's all running, and I'm such a bird brain right now. Which one are we on? Okay, we're on the x86 one. Cool. So I'll zoom in here and just show that we're doing all the same things, same code here, from a single repository. Again, we have the OS architecture. So let's go code, do a maven package, build this guy. And then we'll also just deploy it so we can see that everything is working okay.
So we've got two instances, different applications, but same application, but different OS underneath, right?
Yeah, different processors. They're same operating system.
Different processors, sorry.
Cool. So that's all running okay too. Oh, I don't know why the other one didn't prompt me, but there we go. We have our website up and running. So
Okay.
this is kind of like the perfect scenario, right? We didn't really have to do too much. We had all the appropriate libraries. Let's talk a little bit about if you have a lot of different applications to choose from. Let's go here. So let's say you have a lot of different applications to choose from. Some of our customers have like 40 different workloads and they're like, where do we start? Because we can't have every single one of our teams migrating over to Graviton. Also, you want to get a feel for what that experience might look like for your particular teams. So we do have a tool called the Porting Advisor, and this is the software inventory portion that we typically recommend our customers to start their journey in identifying what is the lift. That's always such a common question, is what's the lift to move to Graviton? And I wish I could give that answer, but I'm not your scrum master. I'm not your developer. I don't know what's in the code. So it's really hard to answer exactly how much time. It could take a week. It could take a couple weeks. It could take months. That's really going to depend on your code hygiene. So one way to check your dependencies as far as software goes to see what needs to be changed, we have this tool called the Porting Advisor for Graviton on GitHub, and you can just clone it. It's a script that runs locally. No information gets sent back to AWS. It's all analyzing your code source tree directly within whatever system you're running on. There's no API calls, totally self-contained, and it scans Python applications, Java, Go, C, and C++. If you have a language that you want analyzed here, do add a ticket in the issues item to help the team know where to direct their energy and see who needs the most help with specific languages. But it's very simple to use. There's a containers option. There's also a Python script option. I typically gravitate towards this. So I have the environment variable already. It took like, let's see if I can.
And one thing while you do that, Hanara, Steph, you were kind of mentioning, like, if you're in FinOps, show people this video for your dev teams. I would specifically say grab that link and show that to your teams as well, because that's something I use a lot with some of my customers that maybe have some hesitation of moving to Graviton, and there's a lot of assumed effort that it takes in moving to Graviton. This tool is so prescriptive in telling you exactly which some of the libraries or dependencies you have that will need upgrading. And so if you're looking to size what that effort will be, as Hanara mentioned, like, this is the perfect tool, and it's so helpful for teams.
Perfect. And we have someone asking in the chat, are we converting x86 apps to ARM64 using AI? But we're using these tools like Porting Advisor and how to natively do it, right?
Yeah, so there's no AI in here. You might even be much smarter than this script. All it's doing is looking at common libraries. So there's one caveat, is that it's not going to capture everything. I really recommend this more as like a planning stage to understand what the lift might be. The most accurate picture of what you will need to do and fix to get it completely compatible is going to be building it on a Graviton instance, looking at the error messages, fixing those libraries, and then running it and doing your unit tests. That's essentially like an even smarter Porting Advisor, because you're using the actual compiler and build system. So that's what other customers did in the past before Porting Advisor, but this is really like for planning. If it comes back saying there's 40 things that need to be fixed, obviously that's not where you would want to start. If like this application these are all the recommendations that came out. That's probably an application you would want to start developing with.
Okay.
So another thing to know is it might also capture a couple of red herrings. So when you do run this and you get like 100 messages back saying something is not compatible, if it's not part of your build, but it's just in your source code, it might still work, right? But only you know, because you know what's in your build files, you know what's going into specific builds, especially if you have multi-architecture libraries. It's going to show that, whoa, this is not ready for Graviton. But depending on how it's being compiled, it might be perfectly and totally ready for Graviton. I'll show a quick example, since we didn't really get so many recommendations here. I'll show a quick example of Porting Advisor. If you did have something that needed to be fixed, so it'll tell you the exact line number of a specific file and give you a comment on what needs to be upgraded.
Oh, wow. Very specific. I love it.
Yeah. So sometimes it'll give you the exact answer. And there might be situations where you've completed everything that's on Porting Advisor, and there might be a couple other loose strings to tie up when you actually do the build and your unit tests. And, really make sure that you ensure during runtime, not just build time, that everything is compatible. You don't want to call an API and then find out that the library doesn't exist. Okay.
Worth noting, Hanara, you had linked the Java section of the Graviton Getting Started guide, but we also in there have a page for a lot of the supported languages. And there's a lot of really great insights for any language if you're using Python or Go or something like that. Probably some preliminary things that you can do before running Porting Advisor, but it has a lot of prescriptive guidance on what it would take to move to Graviton for each language.
Yeah, I think I literally looked at Python. It was just update, and I was like, okay, that was the main recommendation. One more thing before we move on. So Porting Advisor says it scans dependency versions of requirements.txt file. Do you know if it will also work with poetry, i.e., pyproject.tom files or toml files?
I'm actually not sure.
I tell you what, in I think that's Olian. Please feel free to email us at costoptimization@amazon.com with that question. That'd be really helpful. Otherwise, or pop it as an issue on the GitHub repo. Either of those, because we want to make sure that we answer your question. Okay, Hanara. So we've run Porting Advisor to see what the lift is. What's next?
All right. So we kind of went ahead and already did the test. So you can go either way. After you do that, then you would do what we just did with building everything, running it, making sure it's okay. So we know that everything builds and build time. We pinged it once, but the next thing you would want to do is to run some performance tests. You can just lift and move things over into the Graviton instance as is, but we'll talk a little bit about performance in depth as well, and why not doing a performance test and understanding where your new threshold might be could be leaving a lot of just usage of your instance on the table. So, okay, I forgot again. What is this one? Okay, it's ARM. Okay, cool. Let's do let's do our performance test on here. It doesn't really matter too much where you run it. Okay. So I would have to run my code again. Let's do that. Even exec Java. Okay, so nope, that's not working. Why aren't you working right now?
Oh no, live errors.
I probably just didn't type in something right. Around this and you're okay. Okay, there's a typo. Okay, so I'm logged into a separate instance here. You don't want to run your load tests and your application on the same instance. For obvious reasons, it's going to get really skewed results, and it's going to just not really provide you helpful data. So I have this load test server here. It's on a X large instance, depending on what your application is and how much you're trying to load you're trying to push onto your instance. You might have to change the t-shirt size of your load generator instance so that it's powerful enough to actually send something that matches production. So since this application here has a post method, we need to first create a config file so that sorry, I'm also a little bit under the weather, if you couldn't tell.
Bless you. Just trooping through doing a demo while not being well.
Yeah, just making like sick person noises in the middle of the silences. But okay, so cool.
You're doing great.
And this is application, JSON type, and then and you could create your own script, like actually the text file too. Let's see. So the work body, yeah. Prompt. And then let's give it a prompt. Simple steps. All right, cool. We've given our chatbot a prompt and sending in a couple of tokens and
just for people who don't, and that this is very specific to the application you've got, and just sending out a kind of message that would be mimicking what would normally happen to this application, right? The chatbot.
Yeah, so I definitely also wrote this wrong, so I'm gonna have to update it in my
No worries.
do I have Vim in here? No, I don't. Wait, I do. Thank gosh. Okay, it's easier to see. All right. So we have our post message set up, and now we are ready to send in a WRK command. And work is a benchmarking tool. We're using WRK2. This is a modified version of the original WRK work. And this is typically what we recommend to use because it has a more consistent throughput of load that's being sent to, and it has varying percentiles that it shows you, latency percentiles. And there's some load generators that are what you would call a closed system load generator, and it works with the system to show you inaccurate results. Like they're like, it's kind of sweet because it's like the closed load generator is like, oh, you have too much work. That's okay. Do what you got to do, system. Like, I'll wait for you before I send in this next group of requests in, which is not reality, right? Like, we would hope that our customers on the other end is like, oh, actually, let's not scale up that instance because it's working a little bit too hard already right now. So having an open system load generator gives you that real life or more real life experience of there's no coordination of working with the load generator and the actual website together to form inaccurate results.
And we've also had a question, which I obviously don't know because it's not my area, but what is the name of that prompt pattern where you fire it without a row in this post situation, if that makes sense?
Wait, sorry, one more time.
What is the name of the prompt pattern where you would run this code without a role? They're asking about why there's not a role needed in the prompt that you just did. Is that?
Oh,
that make
like
sense?
me or like human? I'm actually not sure. So this is Llama C++.
Okay.
I don't know if it's because of the library thing. I'm not a Gen AI or LLM expert. I am just a customer.
No worries. No worries. Hopefully that answers the question. Okay, so where are we up to now?
So now I'm going to start sending some load to this instance here. Just make sure I have the appending ports. So would just love it if things could go perfectly from the start. Okay. No, okay. It's blank, but that means it's working. So this is going to run for 5 minutes. We'll come back to the results. Not to like do any intense analysis, but just to show what the outputs are, how you might use those outputs. And so we just sent in a WRK command with 1 connection, 1 thread. It's going to run for 5 minutes, 2 requests per second, and it's just sending this token 2 times per second. Cool. And then you can do the same for the other, but really whatever test instance that you are trying to figure out how your application works on, you'll run that load test. And depending on the application, you will find that the latency of what you had previously had, if you were on x86, the threshold is higher. So if you were breaking latency earlier, like let's say at like 60%, 40% CPU utilization, that amount of utilization can bump up without breaking that latency. So we'll talk a little bit about that just because it could be kind of, if it's your first time hearing about it, it could be kind of confusing to understand where the price performance comes from. So Rem, do you want to talk a little bit about this?
Sure thing. I mean, I think one thing to start by pointing out is you're talking here in latency. I hear a lot of times when customers are testing out Graviton that they'll mention, testing out CPU performance or some other metric. But I think the first thing to mention is that it's really important to measure this in some kind of SLO that is actually important to your object or to your application.
What does SLO stand for?
Service level object, or what is
agreement?
The
Wait, yeah, objection. No, sorry.
Yeah, no. Too many acronyms in the head.
Yeah.
Yeah, I was like, which one is it?
Yeah, it's a basically
service level objective. Okay.
I thought it was objective.
Really had to get that.
Sorry, Rem, keep going.
Defining metrics and key ways of measuring your application. And so like if you're looking at the performance of your application, the actual CPU utilization under the hood doesn't matter. And I think that that's why looking at something like a graph on the right is very important. And Hanara was mentioning that typically we will see on, for example, an x86 architecture, that CPU starts to have increased latency around 60%. And one of the under the hood things with Graviton is that each vCPU on Graviton represents a physical core, whereas on like an x86 architecture or ARM, for example, these are virtual cores where they will do simultaneous multi-threading. And you don't do that on Graviton because each vCPU has a physical core. So we are able to run that a lot higher, maybe up to 90%, for example. And so this is going to allow you to do more on a single Graviton instance. And so again, you should probably be measuring something like latency or error rate or something like that. Not just what is the CPU utilization and trying to match that to Graviton, because that's not how you're measuring your application.
Yeah, great
Okay.
points on we also got CPU utilization as a metric a lot, and there's just so many ways that it can go. Does that mean that it's better because it's utilizing your instance more? Does it mean it's worse because something else is going on? It just opens a bigger can of worms than giving you real answers.
Mhm. So we're saying you can use an instance, I say more is not the best way, but use more of its CPU with Graviton because it has like the capacity to do that. But but that's not a good measure of how well utilized it is. So use things like latency and error messaging, right?
More
Yeah.
so that you want to like Rem mentioned, have a KPI, some kind of metric that you're going against.
Mhm.
And you should be able to push it further while still meeting whatever that level of requirement is for your application.
Okay, cool. Makes sense.
Yeah. And sorry if I just repeated. I don't know where I went for like
No,
5
no, no.
seconds.
That makes sense. It's all good. It's all good. I want to check because that's Rem's right. You're both right. When and I haven't looked heavily into Graviton kind of utilization metrics. Normally we say, I've seen it where it's good that people have moved to Graviton, they use yet less CPU, but haven't explored this idea that like CPU is not a good metric for this. So we're just so used to doing that. So especially as freelance people that are watching, this is something that you need to speak to your developers about the applications that are actually on these things. Okay, so we've learned a little bit about how to kind of do this load testing, how to measure it.
Mhm.
What's next?
Yeah. So actually just one more thing of
Yeah.
tying this into optimization. This is where the price performance comes from, right? Because let's say just for simplicity's sake that you're running half utilized on all of your fleets previously so that you didn't run into this hockey stick spike. And that hockey stick spike happens across servers. It's like when there's resource contentions and the threads start to fight for resources. So it peaks up like that. It's like waiting in line, a really long line basically, to get whatever transaction you need done. Um, so when you think about that, and let's say on Graviton, you can run like 3/4 as much per box, you add those together to how many instances you do need, and you find that you've really been able to cut down your fleet, when you scale. So that's why the performance and understanding where you're breaking your latency or whatever, again, your service level objective is. Because you might find that, hey, instead of our previous auto scaling configuration that said scale up for more instances at 60% utilization, maybe on Graviton it's 70 or 80, depending on the workload, right? If you have really spiky workloads, you want to give yourself that buffer for scaling more instances. But if you have something that's more condensed and predictable, you might even be able to run it up to like 80, 90, and that can really help reduce the amount of compute that you're using and waste in general.
And just to really emphasize that, I think the two words that are important there from Hanara are price performance, and that's really important to consider when you're moving to Graviton. So you're not just moving a C5 X large to a C7G X large, and so you should really think about that, especially if you're in FinOps, is that you might be able to size down, you might be able to use less instances. So it's really important to test. Also, if you're in a FinOps role, we do have a tool available called the Graviton Opportunities Dashboard, where if you are doing this type of testing, you can input things like your performance gain that you're seeing with Graviton, and also get some exact cost savings. And so that's a really good tool to evaluate your actual potential savings on Graviton.
Perfect. And Rem came on and spoke about this before, the dashboard. So you can always check out the YouTube video where we goes into detail about it, which I will share in the chat, but also we'll put on the YouTube notes below. Okay, we've got about 10 minutes left. So what
Yeah,
is our next
like
stage?
let's race through
Let's
this.
do this.
So, now that you've tested, you know where you want to scale for your performance after doing your performance test, and you're ready to deploy into your infrastructure changing your AMIs, making sure your infrastructure is using Graviton instances. So if you're using something like Terraform, whatever it might be, the things that need to be done are for the most part pretty straightforward if you already have your infrastructure built out. So here we have our ARM AMI, ARM parent image and instance type defined. And we'll see here that the image builder right now is using x86. So if you were to copy and paste essentially and change it up to use Graviton, you would just append it with ARM and then add a G basically. One thing to note though, this is where customers also get tripped up, is that the comparable generation is one number off for Graviton. That's to show that Graviton is always a generation ahead, but it gets confusing. I've had customers come to me and say, I'm not getting that expected price performance between C6, whatever, x86-based instance and a C6G. And usually the call lasts 5 minutes. So like try that on a C7G and you should see that price performance improvement. So just be mindful of that when you're doing this updating. And maybe you might find that you just prefer Graviton 2 as well compared to the 6th generation x86. Who knows? Why not test all of them if you're able to? So the next thing that we have is our image pipeline. We're using EC2 image builder here to build our AMIs. This is already built out, but if you are curious, the workshop is public, I think, and you can see the difference between the two image builders. So again, like the structurally, it's all the same except for the environment variables that you're using, which you've defined in your main Terraform, or if you're using CloudFormation, whatever environment variable that you're using. And then for the auto scaling group, the launch template that it's using is the x86 launch template that's defined here. So we would just change that to ARM. And then we would just change this to ARM. And the code pipeline that we have, they are using, this is just pushing the infrastructure. So this is separate from the actual application code, and then it should deploy into ASG with the updated images. So if you're using EC2 image builder to create your AMIs, similar process, just install the app through your, if you're using like a run script or something, you would just pull in the code to create your image from there. And that's all pretty standard EC2 builder, image builder stuff. One thing I did want to mention though is how you would start deploying this into production. So maybe you want to just move everything over all at once, but typically we recommend having it split for a little bit just to monitor performance, seeing if you're getting what you need. A lot of our customers have made the slower transition through like a green blue deployment, having some loads sent to x86-based instances, some to Graviton, and then slowly move over, or they've just stayed multi-architecture if you're utilizing things like Spot. Because at the end of the day, even if it's different processors, it's just more instances to choose from. And if you have Spot heavy workloads, being able to have even more instances is always a big plus. So you can have the two build agents like we saw in the code pipeline and then deploy it there. And you can see here that we have an x86 code build and an EC2 code build. You want to use you want to do native builds with the matching architecture. There's things that can happen if you use things like BuildX and emulation that we can't get into, unfortunately. But final thing I wanted to leave you guys with is here in IntelliJ, Java folks probably you're more familiar with using this IDE. So just showing you what it looks like here. And my queue chat is frozen, but that's okay. Super simple to use, actually. You install the AWS toolkit for core and AWS core, and you just open up the tool chat. You say transform, and then it'll identify. Oh, it's already upgraded for me, but it'll identify which application is in the project that you have open. Click transform. This took 15 minutes. This is a fairly small application, though. It could take up to 55 minutes. And what it does is it builds, and then it sees what broke for the next version of Java, and then it goes back and fixes it, builds it again, and then eventually it gets to a successful build. From there, there'll be some code changes that it made. You can accept it and then push that into code commit. One thing to note, though, in the demo, we did have the visual editor open through a remote connection. Amazon Q, I don't think you can get through remote connections. So the difference in this format would be just pushing it into your code repository and having image builder pull from that to do your testing. So if you're already doing a migration, I highly recommend just getting a upgrade of Java versions as well if you are on Java, and really boosting your price performance in that way too. And then another caveat is just that there are some prerequisites to make sure your transformation is successful. So don't want anyone running this, banging their heads, wondering why isn't it just working. There are some caveats to what is possible, what can be used. You might have to split up your project because it can't be like way too big. So definitely go through the docs first and make sure your application can work for something like this. But yeah, that is the whole demo. Really speed rounded the last 10 minutes.
That's great. And so anything else in the last like 2 minutes, Rem? I've thrown it to you for things like when you're looking with customers that you've done this with, is there anything you suggest people who would need to do it at scale, like what the good processes is, anything to like target? Obviously, you mentioned the dashboard, but anything else you recommend?
I mean, I think the Graviton Getting Started guide is just so rich with everything. I think that you can really answer a lot of your questions there if you have them. I've just used that as my own personal reference, just reading through some of these pages, especially with like some of the languages I'm more familiar with, and reading through and understanding them. And you can also get an understanding of what languages are easiest to move, starting with interpreted languages and bytecode languages, with compiled languages being harder. So it gives you a lot of detail there that might help you for kind of stack ranking your different applications. And I believe also talks through some managed services as well. So like managed compute for Lambda and Fargate. And then also like other managed services, RDS, OpenSearch, Elasticache. So those are all really good resources there. It has the porting advisor and other tools in it. So I think that's a really good one-stop shop.
Perfect. And that was then. So hopefully you've now seen that there's like a few processes. And for those in the FinOps people who are like, well, that's went over my head, share with the developers. The resources that we've shared today will also give some guidance, but that kind of build approach. And I really liked now what you said about Spot, like the way you said it of having both types built so that you could have access to more instance types. It's just a clever way of putting it, because then you get a wide variety and you can always use the cheapest one. So that's great. Very funny, silly thing before we finish up with our summary was someone commented on the first view, dark mode, please, which I thought was funny, but it is a personal preference. So I'm going to say just a very last minute poll just to finish us off. Are we a light mode or dark mode people? I just had to go and look, 1 for light, 2 for dark. I had to think about it because I had to go and flick through my screens to be like, am I a dark mode or a light mode? I'm actually just default mode. That's my vibe. I'm always the one that whatever the laptop has set up for me, that's what I do. Okay, a lot of people are saying dark mode. Interesting.
Don't worry, Nara, I stand with you on light mode.
I used to be light mode, it changed.
I usually do light for presenting because I feel like whenever I watch a dark mode demo, I just start falling asleep. It's like light ASMR, like dev ASMR. And then the light just like wakes me
Soothing.
up. But yeah.
That's excellent. I've not heard that before. Okay, let's do our quick summary. So at the end of every session, oh, let me get this up. We always have a quick summary from Richard's, a secret Richard summary. And of course, the screen's going wild and showing everything. But I'll just do it on this. Graviton is great. That's great. Plan with Pausing Advisor, a really useful tool to get you started. Skip CPU and measure your latency and errors instead. And finally, use Amazon Q use Amazon Q Developer Agent for code transformation because it works. I love it. Amazing. Okay, that is it from us today. Thank you so much to my amazing guests. Hopefully you've seen this and you're inspired to now go out there and move to Graviton. As always, if you have any follow-up questions, feel free to email us at cost-optimization@amazon.com. And FYI, I'm away for 2 weeks on holiday, fun times. The show will still be happening live, but there will be a little delay for it coming on YouTube. So if you wonder, we'll be gone. That is all. But I will see you guys when I come back. Thank you so much. See you next time.